Alright, we're going to give this a shot here. First lesson on the virtual lessons are pre-calculus, applying the different forms of the parabola. So you guys should get out this sheet. I will have attached it next to the video. Get that out, and then you're going to follow along with me, or you have already completed it. First question that we're going to do, part A, using vertex form, write the equation for this parabola. So using vertex form, the first thing that I'm going to do is I'm going to write down the actual vertex form, which is y is equal to a times quantity x minus h squared plus k. And from this form we know, the most important thing about this form is that the vertex is going to be hk. And from the graph, we see that our vertex here is at 5, 4. So our h value is 5 and our k value is 4. And we're going to put that into the form that we started with. It's going to be x minus 5 squared plus 4. And now we have to find the a value. And we're going to find the a value by looking at the graph and seeing that on the graph goes through, this parabola goes through the point 1, 0. And we're going to use that point, 1, 0, and that will be our xy that we will use to find that a value. So we're going to plug in the 1 for x and the 0 for y, and then solve it for that a value. Writing that out, I'm going to write it out like this. Then we're going to go ahead and put the 1 in for the x and the 0 in for the y, and then solve for that a. Get a negative 4 squared plus 4 is equal to the 0. And then this becomes a negative 4 is equal to 16a, and then solve for the a, we will get negative 4 over 16 and negative 1/4. That will just go in for the a value right here. Y is equal to negative 1/4 x minus 5 squared plus 4, and that is the vertex form of that parabola. Looking at question B, it says using factored form, write the equation for this parabola. And again, like part A, we're going to write out the form for the factored form, which is y is equal to a times quantity x minus r1 times quantity x minus r2. Our r1 and our r2 are the roots of the equation. According to the graph, I see that one of the roots is 1, 0. And we don't have the other one. The picture kind of cuts off there. But I do know that 5, x is equal to 5, is our axis of symmetry. And since 1, 0 is a root, that would make 9, 0 also a root. I'm going to use those values and put in for r1 and r2. Minus 1 and x minus 9. And again, like the vertex form, we're going to have to find the a value. We're going to do that by finding a point on the graph, an xy point that we can plug into this form to find that a. I know from the problem before that our vertex is 5, 4. We're going to use that 5, 4 for our x, y. y is equal to a x minus 1, x minus 9. For our x values, we're going to use that 5, and for our y value, we'll use that 4. And then we will solve for a. This becomes a 4. And a minus 4 is equal to the 4 on this side. This becomes a lot like the last problem. 4 is equal to negative 16a. Solving for a, we get negative 1/4 again. And we are going to plug that in for the a right there. Y is equal to negative 1/4 times the quantity x minus 1 times the quantity x minus 9. Box that up and then move on to part C. Part C says, using either equation, find the y-intercept of this parabola. We see that from the graph, it looks like our y-intercept is a little less than negative 2. And I'm going to use the first form, the vertex form. And that was y is equal to negative 1/4 times the quantity x minus 5 squared plus 4. Find the y-intercept. We need to make that x 0. Rewrite the question, or rewrite the equation. X minus 5 squared plus 4. That x is 0. And then we're going to find the y. Negative 1/4. The inside of this quantity is negative 5 squared plus 4. We're going to move the 4 to the other side, and it becomes negative 4 is equal to negative 1/4 times 25. I'm sorry, that 4 goes on this side. We're going to leave it there. And it becomes negative 25 for 4 plus 4. Adding these fractions together, we're going to get a negative 9/4. And that is going to be our y-intercept. Our actual y-intercept is going to be the x value is 0, and the y value is negative 9/4, and that number is actually a little less than negative 2, like we see here on the graph. And box that up, and then move on to the next part. Part D asks, the point 4a lies on the parabola. Find the exact value for a. So again, we can use either one of the equations that we found before, the factored form or the vertex form. I'm again going to use the factored form. And I'm going to write that out. Y is equal to negative 1/4. X minus 5 squared plus 4. And then it says if 4a lies on the graph, so we're going to just plug in the 4 in for x and then see what we get for the y. Y is equal to negative 1/4, 4 minus 5 squared plus 4. This just becomes negative 1/4 minus 1 squared plus 4. And negative 1/4 plus 4. And finding that fraction, we're just going to the 15 over 4, which looks to be about, at 4, it looks to be a little more than 3, a little less than 4. And that's what we got here, 15 over 4. We're going to box that up and then move on to the next part. And that is, on what intervals is the function decreasing? Now from here on out, we have most of our information, and we're going to use it to answer the rest of the questions. It asks when is the function decreasing, and the function looks like it's decreasing from the vertex, so we need to use the vertex and then on, and that is the interval that this function is decreasing on. So, and we're gonna write that out as the vertex is 5, 4, like we found before, and it is decreasing on the interval from 5 to infinity. We're not going to include 5 or infinity, and that is when the function is decreasing. Moving on to the next question, what is the range of this parabola? So we're looking at F, part F. The range of this parabola goes from, as it goes down, negative infinity on up to the y value of the vertex, which is 4. So the range of this function is negative infinity. We're not going to include that, and then 2, 4, we are going to include that number. And then part G, as you can see from the question, it's asking to find the points B, negative 12, and C, negative 12, and the exact answers, exact numbers for B and C. So we want to find B, negative 12, and C, negative 12. So let's use the equation again from the vertex form, which is y is equal to negative 1/4 times quantity x minus 5 squared plus 4. And I just need to set that y equal to negative 12 right here, and then go ahead and solve for the x. It would be negative 12 is equal to negative 1/4 times quantity x minus 5 squared plus 4. And then go ahead and solve for the x. So we're going to move the 4 to the other side. It's going to become negative 4. Negative 1/4 is equal to the quantity x minus 5 squared. The negative 16 is equal to negative 1/4 times quantity x minus 5 squared. Multiply both sides by a negative 4. And this becomes, we're going to multiply both sides by the negative 4 over 1, negative 4 over 1. And this becomes quantity x minus 5 squared. And this becomes 64.